So let's go to Q&A session. MHD is kind of a rarefied topic. So, but again, and let me check again, I should write this down better. I believe it is Option Y on Mac or Alt Y on Windows to raise your hand. Michael, would you like to go, sir?
So, Will, I'd like to make a speedboat with one of these. You know, a battery-powered speedboat that would use the ocean water as the propellant.
Well, I think the Yamato went about 6 knots, right, Will? Didn't it?
Well, you know, you got to upsize it. You got to start out small with a little model, and then with some like salt water in the tank, and then get it up to a bigger size. I could see this could be the Tesla for water sports.
Well, actually, just before the Yamato, they had because of the problem with the superconducting coils, right? They had to build a 1.5 meter scale model prior to building the Yamato to test out the designs for the coils. Originally, they were going to use a pancake design, but that sort of exploded. So they decided that they had to go to the saddle design, and that's where it was. Unfortunately, for that time period, YBCO and other high temperature superconductors were not widely available. And as I was actually working with professors at Osaka University at that time, there was some serious problems in YBCO because they were using the pit technique, which is basically powder and tube. And when they rolled it out, it wasn't always even. So I actually burnt up quite a few pure silver tubes myself.
Now, Will, if I could jump in real quick, one of the things when you're running current through seawater, if I understand correctly, you can, if you go over a certain threshold, you actually start to pull chlorine out of the salt, right? Do you know?
Well, yeah, I'm sorry, go ahead. Yeah.
Oh, I was just going to say, I mean, I'm not sure. Does that limit the practicality of these devices?
Actually, in the case of Yamato, and I didn't put it up there because the water actually became very dirty from the chlorine, as you said, when the copper reacted to the salt, a lot of chlorine was produced. In the Yamato's case, they put a fiberglass, what do you call it, shield on it to protect it from the corrosion of the seawater.
Okay. So, and again, this goes to Michael's speedboat idea, right? But so if you wanted to go faster, you'd have to run more current, push against that. But you run too much current, you start to pull chlorine out of the water. So
the silicon nitride passivated copper. Right?
Well, as they were able to, I mean, you know, the superconductors were 5,000 amps, but the charge on the anode and cathode was 2,000 amps. So they had enough current, I think, to overcome the resistance of the fiberglass, and the fiberglass protected the copper, the huge copper plates or bus bar essentially, from actually reacting from the seawater. So I suppose that they would have had to have some maintenance on those fiberglass sheets, but the bus bar should have been very well protected.
Okay, thank you for answering my question.
and Michael, thank you as well, sir. Let me go to Gary. Gary, welcome, sir.
Hi,
I
Gary.
just want to say thank you so much, William, for that talk. That was some fantastic background on the Yamato. I don't know how you got your hands on all that, but it answered a lot of questions I had. The part I don't know yet, and maybe you can estimate, is if they had had your YBCO nanowire at the time, how much more efficient would that Yamato 1 be? And what sort of speed would you get that speedboat that we're looking for?
Yeah, I think you would have got your speedboat. Yeah, most certainly you would have got the speedboat. I think the efficiency would have been amazing. And the fact that you can switch from helium to liquid nitrogen, that's huge. And we really see that actually in our superconducting windmills. Maybe I'm not sure if a lot of people know it, but most of the windmills now are actually superconducting. And
I did not know that.
they have motor generators, and they use different layers of superconductors in order to not, so because you need a magnetic component and you need an electrical component, right?
Sure.
So, and how do you do that in a superconductor? There are ways to do it. And those are usually trade secrets for each company. So I wouldn't be privy to any of that, but the way it appears to happen, because my lab tests a lot of superconductors, is that at one temperature, the electricity is actually superior in the wire. And then at another temperature, the magnetic field is superior in the wire. So by being able to change the character of the superconductor according to the temperature, you can make motor generators, and that's what they do in the windmill turbines, like they have out in the North Atlantic or whatever. However, the other point of that is those typically operate only at 20K, 20 Kelvin. And that is an industry standard. So if you're looking to build a large craft that's superconducting, 20K high temperature superconductors, that's what you're looking at. Now, if the Yamato had that, you would have looked at, you would have seen a boat the same size, perhaps, but they would have had enough room for passengers. That boat could fit about 3 people, 4, maybe. You're pushing it at 5, okay? So, but if you would have had, if you would have had the more modern technology, it would have been a passenger craft. So,
can I get one more quick question in on you mentioned cesium as a seeding for your plasma, for the plasma MHD. Could you expand a little bit on why you think cesium is a good seeding material?
Well, actually, I got that out of his name Pierre Pont? Do you remember his French name? Petit.
Yeah,
right?
Petit.
I took that out of his material.
I see. Okay. All right. Thank you.
Yeah. Well, so thank you, Gary. Let me go to Harold Tavares next. Harold, sir. Oops.
Hey, thank you. That was a great presentation. And I have a question for you. It's kind of a speculative.
I'll try.
A superconductor device.
Harold, do you think you could stop your video? Your bandwidth is really low. I can't hear your voice.
Oh.
Try stopping your video. Normally we don't do that, but
Okay. Can you hear me?
A little bit better. Yes. Go ahead, sir. I'm sorry.
Speculative. I was wondering, in the 2019, you gave good calculation on the amount of Lorentz forces that is producing and the gravitational forces, the gravitomagnetic forces there. And so I thought, well, can magnetohydrodynamics be used to create a warp drive? Because in that case, using forward design, the toroidal design, the donut shape, and have a lot of plasma, magnetohydrodynamic plasma flowing, producing a lot of gravitomagnetic forces that would create a distortion. It would create an internal light. Be applicable, to build, because that would qualify portions on a space-time using magnetohydrodynamics to use the forwarding, the nanotubes you invented, and that project to engineer a practical warp drive. Not possible.
Okay. So Harold, you're cutting out, but let me see if I can interpret that. I think what you're asking about is gravitomagnetic forces from the magnets, right? And
yes, they produce a toroid that he in his 2000 this portion system. Now, in his is producing a lot.
Did you get that?
Yeah. So yeah, Harold, let me
that be used doing hydrodynamic drive.
Yeah. So Will, I think what he's asking is if the gravitomagnetic forces that are produced by these magnets could be used to produce some kind of a warp drive type propulsion, right? I think what he's wondering is if you could bend time space using that.
Not that I'm aware of.
Yeah.
Yeah, but
Yeah, well,
however, if he's interested in that, he can take a look at the paper that Gary and I and Dr. Teed and I produced for Grossman 16.
And even
that
with the
was
forward
also-
design.
I believe that was also reprinted. Is Gary still here?
Yeah. Gary's up there. Yeah.
Yeah, I was just going to mention that it's even with almost 1 billion miles of wire in this toroid, and your wire is very small, but you can't make 1 billion miles yet.
Not yet.
With 1 billion
no.
miles. The effect is so small as to rival measurement capability. So we're talking about a very weak effect. This is the bottom line.
Yeah.
So,
Yeah. Well, so let me see who else has questions. And again, that's Option Y on Mac or Alt Y on Windows to raise your hand. And then let me see. It looks like we have some links here. Robert dropped one in chat, demonstrating magnetohydrodynamic propulsion, some boat experiments. And let me see, I'm not seeing any questions though. It looks like these are mostly just comments in chat. So.
I made a mistake the first time, but the last two links work. The one with the propulsion in a minute, that's a simple experiment that really worked, at least for me. And it's really neat seeing the water going past the two electrodes.
yeah, I do know that there are quite a few experiments like that for copper. I just wanted to do it myself and make my own photos or videos, and but I have not seen anyone make a transparent version. I've not seen anybody do that yet.
No, Will, when you say transparent, you mean a transparent demo with the dye, right? So you can see the dye move through and.
No, no, if you, shall I go back and take a look at that?
Yeah, yeah. No, I'd love to see them again if you want to put those back up. Yeah, just hit the screen share button and
Actually, I gotta.
and
Oh.
again, thank you so much for presenting today. I'm excited. I mean, this is like, I think you've probably been to 20 or 25 at these conferences, so it's good to finally get you to present.
Yeah, well, I'm happy to present, so, but I've got to figure out,
I always feel guilty because of the time difference.
don't worry about that, Tim, it's fine. So what I should show is, when you look at this picture here, oh, sorry, I can't see it. You can't see it yet, can you? I can't seem to share what's going on. Is there a button I'm supposed to press, Tim?
So the screen share button is, it should be, if you're on
there
your
it is.
PC, yeah, green button, bottom of the screen.
Okay, there we go. Oops, sure. Okay. So is that okay? Can
Yeah,
you see
yeah.
that? Okay, so here you can see that I can't zoom in, so this material is the anode and cathode are completely clear. These are actually made of nanomaterials. So when we run it, then you can see that it's actually, yeah. Here's where we get the breakdown. It just dies. So the voltage overloaded the plastic substrate that the nanomaterial was on, and it died. So I hope next year we can show a much better working version of that to you.
Do you think that you could build like a remote control model of this? I mean, or would that be?
Well, actually, I'm already planning to build a small remote control device using the transparent materials. So.
And the nanomaterials help the charge. They help the charge move better, right?
Yeah, the nanomaterials just make it lighter. The charge, the charge doesn't care what it goes through. So the nanomaterials just make it much more lighter. So like I was saying here, the transparent magnets, we have those. Upgrade the nanomaterial itself. And I'm actually looking to use hydrogen this time instead of water. So.
MHD and hydrogen. So that would have to be a sealed system then, right?
Well, no, I have a way to store huge amounts of hydrogen in a solid material. So we would use the solid material as a cedar, like a cedar, and the hydrogen would be released. Yeah, we could build a very small device, actually.
Okay, so let me go and see if anyone else has questions for Will. And again, that's Option Y on Mac or Alt Y on Windows. And I think somebody was teasing me about Linux. I think they use a Windows keyboard, so it'd be Alt Y on that too.
I actually didn't know that.
Yeah. Oh, Sam, go ahead, sir.
Mr. Rieken, would you rather build a submarine or an airplane with MHD?
Well, I think airplanes are easier. I have a longer history of building airplanes, and I've never built a submarine. So. And water is always a problem. I read an article on Water World, and apparently that was a challenge. So probably going for the airplane is easier.
Now, could you polarize the water? That was something I'd wonder about when I first read about the Yamato. I'd wonder because if I understand correctly, it's kind of a DC circuit, right? So the current's
Okay.
going through, but if you had AC, could you polarize the water and then have the magnets offset? You know what I mean? With an AC current, so that you'd still have directional thrust, but you wouldn't have to actually run the current. You could just, you could just charge the water essentially.
Yeah, my understanding is that if you use an AC, it doesn't interact with the water at all. It generates the force without the actual interaction with the water.
Okay. Yeah.
So, but the problem with the AC at that time period was that there was no practical way to do it without building a much bigger boat.
Yeah, that makes sense. That was, if I remember right, that was what, 1986, 1988, something like that, right?
Yeah, somewhere around there. Yeah.
Yeah. So that was, everything was a lot more primitive back then. So, well, so I think, let me see. I think so we have Mark Sokol with us. Let me see if anyone else has any more questions. I'll do one more open call here. And if not, then we will go to our next segment. So yeah, so I think we're all set. So Will, let me put this back on gallery mode, and everyone please give Dr. Will Rieken a giant hand. Will, thank you again. Thank you yet again.
No problem. Happy to do this.
So let